example number 2, test the convergence of the sequence in curly bracket 2n plus 1 upon 1 minus 3n. So this one is a sequence. Okay. Now here what is n? Here we mean that n is vary from 1 to infinity. Okay. So this one is a sequence, and here the question is that to check whether this sequence is convergent or not. Now for this, first here we are finding the term of the sequence. Okay. Now how to find the term of the sequence? As we discussed earlier, in this nth number of term of the sequence, first put n equal to 1, then put n equal to 2, n equal to 3, and so on. Okay. So now let's start. First put n equal to 1. So we get this first term of the sequence, 2 in bracket 1 plus 1 upon 1 minus 3 in bracket 1. Okay. So here put n equal to 1. So we get this first term. Now in this pattern or nth number of term, put n equal to 2. So put n equal to 2. So we get 2 in bracket 2 plus 1 upon 1 minus 3 into 2. Okay. Then put here n equal to 3. So we get this third number of term of the sequence, 2 into 3 plus 1 upon 1 minus 3 into 3. And so on. Now put nth number of term. So we get this nth number of term of the sequence, and so on. Okay. So all these are the elements we get for this sequence. Now simplify this. So after simplification of this first term, we get answer minus 2 by 3. After simplification of this second term, we get minus 1. After simplification of this third term, we get minus 7 by 8. And this is the nth number of term, and so on. Okay. So all these are the elements, or all these are the terms included in a given sequence. Okay. So all these are the elements of this sequence. Now for this question, to check whether the given sequence is convergent or not, let's start with the definition of limit. Okay. So now take limit n tends to infinity an. So an is what? Nth number of term of the sequence. So here what is the nth number of term of the sequence? 2n plus 1 upon 1 minus 3n. On it apply limit n tends to infinity. Okay. So now limit n tends to infinity an is equal to limit n tends to infinity nth number of term of the sequence. So on nth number of term of the sequence, apply limit n tends to infinity. Now solve this limit. Okay. So now what is our question? Our question is that to solve this limit and check what is the answer, whether this limit approaches to some finite value or infinite value. Okay. Now solve this limit. Again here we know that as per the previous example, as n tends to infinity. Okay. So we know that 1 upon n tends to 0. Okay. So here n is given, try to convert it into 1 upon n form. Okay. Because 1 upon n is some finite value 0. So that's why this is again the algebraic equation. Now what is the maximum power of n in numerator? It is n. Again in denominator, what is the maximum power of n? Again n. Okay. So now dividing numerator and denominator by n. Okay. So after division what we get? Now divide by n. So 2n upon n plus 1 upon n upon 1 minus n minus 3n by n. Okay. So after division what we get? Here n is cancel out. So answer is 2 plus 1 upon n as it is. Here again 1 upon n minus 3. Here n is cancel out. Okay. So we get this value. Now apply limit n tends to infinity. Okay. So 2 is a constant number as it is. Limit n tends to infinity, 1 upon is what? 0. Okay. Again limit n tends to 1 upon n is what? 1 upon n becomes 0 minus 3. So what is the answer? We get finite value minus 2 by 3. Okay. So what is the limit? Limit is minus 2 by 3. So what we conclude? Hence the sequence is convergent and converges to which value? This sequence converges to minus 2 by 3. Okay. So this sequence converges to only single value minus 2 by 3. Okay. So this is the convergent sequence. Now what is the meaning of this convergence? Convergence means this pattern Okay, this pattern approaches to which number as we move on infinity. Okay, मतलब कि ये जो पैटर्न है, ये पैटर्न में हम इनफाइनाइट टर्म तक जाते हैं, बराबर है. तो ये पैटर्न कौन से नंबर को अप्रोच करेगी? तो ये कौन से नंबर को अप्रोच करेगी? ये अप्रोच करेगी -2/3 को. ओके, मीन्स दिस पैटर्न अप्रोचेस टू फाइनाइट वैल्यू. नाउ लेट्स check through the pattern of a sequence, or let's check through the terms of the sequence. So what is the first term? -2/3. So what is the value of first term? First term is -0.6. What is the second term? -1. Third term is what? -0.875. Up to what is the 100 number of term? 100 number of term is, now here put n equal to 100. So what we get? 200 plus 1, 201. 1 minus 300, 299. So 100 number of term is 201 upon 299. So what we get? This is a 0.67. Okay, and so on. So here observe that first the value is -0.6. Then again the value is decreasing. Then again the value is increasing. Okay, but as we move on infinity, we are taking n large and large. This number approaches to which number? 0.6. Okay, so what is the value of -2/3? -2/3 is nothing but 0.6. Okay, so you can also observe the same thing through the terms of the sequence. Okay, but for this purpose we need to do some exercise. Okay, or we need to do more computational works. So in exam, no need to take these two value. Okay, here I am considering these terms only for understanding purpose. Okay, but in exam you should start from this one directly. Okay, directly take limit n tends to infinity an, and on nth number of term apply the limit. Okay, so in exam no need to show these terms. Okay, here I am showing you just for understanding purpose. Okay, so I think you all should understand this sequence is convergent or not. Okay, example number 3, test the convergence of the sequence e raised to n. Okay, now again here n is vary from 1 to infinity. Now let's check the convergence of this sequence e raised to n. Now, as per the definition, first of all, we need the nth number of term of the sequence. So, what is the nth number of term of the sequence? This is the e raised to n. So, an is equal to e raised to n. Now, an, apply limit n tends to infinity. So, we get limit n tends to infinity en. Okay. So, now, the question is to solve this limit. Okay. Now, let's check whether this limit is finite or infinite. So how to check? Here limit n tends to infinity en. Okay, so en means when we put n is 1 to infinity, we get e raised to 1, e raised to 2, e raised to 3, e raised to n, and infinite number of terms. Okay, so this one is a sequence e raised to n. Now what is the value of e? E is approximate equal to 2.71 value. Okay, approximate value of e is what? 2.71. Now check e square, e raised to 3 and so on. So when you put e equal to 2.71, the first term is what? Here we get first term 2.71. Now what is the second term? E square. So from the calculator you can find e square. So e square is approximately equal to 7.38. Now what is the e raised to 3? E raised to 3 is equal to 20.08. Okay, and so on. Infinite number of term. Okay, so now here observe the value. First value is 2.71. E square is what? 7.38. E raised to 3 is 20.08. Okay, so here as we move on infinity, this value is increases. 2, then 7 and 20 and so on. Okay, so if you take e raised to 1000, e raised to 1 lakh, okay, so we get very large number, and this sequence approaches to which number? Infinity number. Okay, so that's why what we conclude, since e greater than 1, e is what? E is approximately equal to 2.71, means e is greater than 1. Okay, so e raised to n increases without bound as n tends to infinity. Okay, so that's why limit n tends to infinity, e raised to n is equal to infinity. So what we conclude, hence the sequence is divergent sequence. Okay, because here we are getting the answer what? Infinity answer. Okay, so I hope you all should understand how to find limit n tends to infinity en. Okay, because en is what? E is what? E is 2.71. Okay, so when you take 2.71, 2.71 raised to square, 2.71 raised to 3. Okay, so as we consider n very large number, this sequence approaches to what? Infinity. Okay, so that's why limit n tends to infinity, e raised to n is equal to infinity. Hence the sequence is divergent sequence. Example number 4. Test the convergence of the sequence tan hyperbolic n. Again, in this sequence, what is n? So n is vary from 1 to infinity. Okay, now we need to check the convergence of this hyperbolic sequence. Now for this we are required to memorize few hyperbolic formulas. Now first one is what? Sine hyperbolic n. So what is the sine hyperbolic n? E raised to n minus e raised to minus n upon 2. Cos hyperbolic n is equal to e raised to n plus e raised to minus n upon 2. Now tan hyperbolic n is nothing but sine hyperbolic n upon cos hyperbolic n. Okay, so what is the tan hyperbolic n? Tan hyperbolic n is e raised to n minus e raised to minus n upon e raised to n plus e raised to minus n. So to check the convergence of the given sequence tan hyperbolic n, we need to put this formula. Okay, now as per the definition, to check the convergence, we apply limit n tends to infinity an. An is what? Nth number of term of the sequence. So here nth number of term is nothing but tan hyperbolic n. So as per the definition, limit n tends to infinity tan hyperbolic n. So now limit n tends to infinity, what is the tan hyperbolic n? E raised to n minus e raised to minus n upon e raised to n plus e raised to minus n. Now the question is to evaluate this limit. Okay, so how to evaluate this limit? In previous lecture we know that what is the limit n tends to infinity e raised to n. So this one is infinity, we already discussed. Okay, previous example. Now what is the limit n tends to infinity e raised to minus n? Okay, so this one is nothing but e raised to minus n. How to write? Limit n tends to infinity 1 upon e raised to n. Okay, now applied the limit, so what we get? 1 upon limit n tends to e raised to n is nothing but infinity. Okay, so the answer is 0. Okay, so what we conclude? Limit n tends to infinity e raised to minus n is equal to 0. Similarly, what is limit n tends to infinity e raised to minus 2n? Okay, so same way what we get? Limit n tends to infinity e raised to minus 2n is nothing but e raised to 2n. Okay, so how can we write? Limit n tends to infinity 1 upon e raised to n, here 2 raised to square. Okay, now we apply the limit, so what we get? 1 upon, what is the limit of limit n tends to infinity e raised to n? So nothing but infinity square. and infinity square is nothing but infinity, so we get 0. Okay, so from these three what we conclude? Limit n tends to infinity, e raised to n is equal to infinity. Limit n tends to infinity, e raised to minus n is equal to 0. And limit n tends to infinity, e raised to minus 2n is again 0. Okay, now use this knowledge to evaluate this limit. Now first of all, here this one, as we know that e raised to n is infinity and limit n tends to infinity. See here, limit n tends to infinity, e raised to n is equal to infinity, and limit n tends to infinity, e raised to minus n is equal to, what we conclude here, this one is nothing but 0. Okay, so that's why here, to remove e raised to n, we need to divide numerator and denominator by e raised to n. Okay, so what is the first step? Dividing numerator and denominator by e raised to n. Okay, so now here divide numerator and denominator by e raised to n. So what we get here? What is the numerator? Here what is the numerator? E raised to n is divided by e raised to n minus e raised to minus n is again divided by e raised to n. In denominator, e raised to n is divided by e raised to n plus e raised to minus n is divided by e raised to n. Okay, so what we get here? E raised to n is cancel out, so 1 minus, now here e raised to minus n upon e raised to n. Okay, so base is same, we move this denominator power n into numerator. Okay, so what we get? E raised to minus n can we write? Same way in denominator, e raised to n is cancel out, so 1 plus, here again this is the minus n, this is plus n, so take this power n into numerator because base is same, so we can do it. Okay, so we can write again e raised to minus n. Okay, so what we have here? E raised to minus n is nothing but 1 minus e raised to minus 2n upon 1 plus e raised to minus 2n. Okay, so you can observe after dividing by e raised to n, what we get? We get this value. Okay, limit n tends to infinity, 1 minus e raised to minus 2n upon 1 plus e raised to minus 2n. Okay, now apply the limit on it. Okay, so here what we discuss? Here we discuss that this one, we discuss that limit n tends to infinity, e raised to minus 2n is nothing but what we get here? We get 0 answer. Okay, limit n tends to infinity, e raised to minus 2n is what? This is the 0. Okay, so now use this knowledge. So here apply the limit. So 1 minus limit n tends to infinity, e raised to minus n becomes 0. So 1 minus 0 upon 1 plus again 0. So what we get? 1 minus 0 upon 1 plus 0. So answer is 1. So what we conclude? The given sequence tan hyperbolic n is convergent sequence because we get the finite value and it converges to the value 1. Okay. Now this one is the example for tan hyperbolic n. Also you can solve for the sine hyperbolic n as well as cos hyperbolic n. Okay, so you can do these two examples. Okay, and let's tell me what is the answer of this.